Hey guys, welcome back to another RASK coding tutorial, and in this tutorial I'm going to be showing you guys how you can implement the QuickSort algorithm using JavaScript or TypeScript. So just to remind you guys, the QuickSort algorithm works like this. If we have a array unsorted array, of course, let's just have 3, 5, 9, 6 and 1, just like that, and we want to sort this into ascending order. So the QuickSort function, QuickSort sort works by first picking an item as a pivot, and usually you can pick any item, but we'll just pick the first item. It doesn't actually matter. So this is our pivot. Now what we want to do is we want to split these remaining items into smaller than and greater than the pivot. We don't have to sort them within that, but we just want to split them into two lists. So we'll just go through each item, and we're basically just going to select if it's smaller than or less than the pivot item. So we can see that 5 is going to be in the greater than one, so is 9, so is 6, but 1 is going to go into the less than. So we split this into two lists, and then we can add the pivot item into either list, but it's usually easier to just add it into the end of the smaller list, because you know all items in this list are going to be smaller. So if you just add the pivot in at the end, 1, 3, and then we have 5, 9, 6, and then ideally this would all be on the same list, because you could just simply move this, swap the items around, but for now we'll just pretend that they're separate lists. And then what we do is we apply the same thing on each of these lists. So we've now split this into two kind of sorted, not really sorted lists. Now what we do is we do the same thing on this, using 1 as a pivot item, and this list is then sorted, I guess you could say. Do the same thing on this list, using 5 as a sorted item, and this list is also technically sorted because you split this into left and right like so. And then what you do is you'd sort this list, use 9 as a pivot item. So if you use 9 as a pivot item, we find that 6 actually has to be on this side of 9. So that's going to give us the left like so, and obviously you just add the pivot item into the left, so that gives us an empty array for the right. And then ultimately, once we've got all of this done, we just join them all back into the main array, just like that. So hopefully that makes sense. Ideally you guys would have understood the QuickSort algorithm before this, and I'm just going to be showing you guys how you can implement it really simply using recursion. I'm not going to be going into the complex QuickSort algorithm, which does everything in one list using swaps. That's a bit more complex, and I'll do that in the future. But for now, we're just going to use a recursive algorithm to split this up into lists using the pivot and smaller than and greater than items, and just recurse down, I guess. So let's call our function QuickSort, and it's going to take in an array of numbers. And yeah, okay. So I'll deal with the break conditions later. Obviously, whenever you're using recursion, you need some kind of break condition, so I'll put that there. But the idea is, let's pick a pivot item, and this is just going to be the first item in the array, and then we're just going to loop through the remaining items. So let I equals 1, not including a pivot item. I is not equal to array.length. And we just want to check, so let's just get this as number. We just want to check if number is less than a pivot, then we're going to add this to the left list. Let's create those lists right now. Left is an array of numbers, and right for numbers greater than the pivot is also an array of numbers. If number is less than pivot, then we're going to add this to the left list. Else, we're just going to push this to the right list because it must be bigger than the pivot. Obviously it could be equal to the pivot, in which case it would just get pushed to the right list as well, which is fine. Okay, so that's what we're doing. Then once we're done, we can either add the pivot into the end of the left list or the right, the start of the right list, it doesn't really matter. I'm just going to use the end of the left list just so I can use the push function instead of the shift or unshift, I can't remember, but push is a bit more standard. So let's just add the pivot item at the end, and now you can see we have two lists, so we're onto this stage, and we kind of just recurse down, doing the same thing, now treating these lists as their own thing. So yeah, and ultimately we just get to, it's just going to recurse all the way down and then send all the results back up the stack. So how we implement that in JavaScript is just by returning the quicksort of left and concatenating it with the right. I should probably make this clear that this returns a bit of numbers just so I have access to that concat function, like so. Okay, there we go. So this is all fine, but obviously we're going to need a break condition, and you might have noticed that if the list, if like the input list is of length 1, then there's no point just doing any sort of like algorithm on it, because we can literally just return that list. And same thing if the input list is empty, like this one here. In that case it's even better. We literally don't need to do anything. So we're just going to check if the array length is less than or equal to 1. And if that's true, we're just going to return the array, like so. So there we go, here's our quicksort algorithm. We can actually test this out by, let's test it out on this array we have over here. So 3, 5, 9, 6, and 1. Okay, and let's run that, and you can see that sorts it nicely. Quicksort is actually time complexity of O of n log n, so it's fairly fast. Merge sort is also O of n log n, and the advantage quicksort has over merge sort is that quicksort actually doesn't use any memory if you implement it correctly, but we haven't done that implementation, we've done the easy implementation. So it's basically the same time complexity as merge sort, both really fast sorting algorithms, and yeah, I think this is actually what JavaScript uses under here if you use the array.sort function. But yeah, so thanks for watching, and that was how you implement quicksort in JavaScript. See you guys in a future tutorial. Bye.